Okay, this is 8.EE.8.a, 8th grade, Expressions and Equations 8, Subpart A, Video 2, Solving Linear Systems by Graphing. All right, a few terms I'd like you to know. Please copy these down in your journal and define them. In today's lesson, we are going to be talking about two equations that are graphed on the same grid. And the standard wants us to realize that when two lines on the same grid intersect at a certain point, that intersection point is a solution to the system. And a system would be more than one equation at a time. And in this particular example, we have two equations at the same time. And the intersection point should satisfy both equations when I substitute that ordered pair into the equations to check them. So the first thing we're going to do is locate the intersection point. Excuse me. And that intersection point is known as the ordered pair of 1, 2, 3 for the x and 2 for the y. And again, that intersection point should satisfy both equations simultaneously if it in fact is the solution. Let's go check that. All right, knowing that point, 3, 2, I have 3 being the x coordinate and 2 being the y coordinate. We're going to just do basic substitution. So let's take equation 1 that was given to us on the grid. This was equation 1. X is replaced with a 3, and the y is replaced with the 2. And let's see if that actually is equal to 7. So order of operations, 2 times 2 is 4. Bring down our 3. And yes, 7 is equal to 7. So we know that the ordered pair satisfies the first equation. Now in order for this to be a solution to the whole system, it would have to work in the second equation simultaneously. So in other words, it has to happen also. And let's check the ordered pair. So we have 3, replace the x with our 3 in the ordered pair, subtract 2 times the y value, which was 2 from the ordered pair. And let's do our order of operations. 3 times 3 is 9. 2 times 2 is 4. It says that we're subtracting them. And we have 5 equaling 5. So that ordered pair does satisfy the second equation, which means it is a solution. They both share it. So it checked out. All right, now we're going to have to do a little bit more additional work here. We're given two equations and two unknowns, and it wants us to solve the system. Now we're actually going to go find out where the intersection point is, if it even has one. And at the end of this video, I'm going to explain a little bit about if it even has a solution. So first, we need to use the graph and check method. So we're going to put our two equations into slope-intercept form. And if you recall from video 1, we spent the entire time trying to convert this standard form into slope-intercept form, which is a little bit easier to graph from y equals mx plus b. So let's take this equation 1, put it into graphing form, and then we'll do the same thing for equation 2. So we'll do one at a time here. All right, we have our wall. Stabilize the y. It happens to be positive. Take this negative x term. It belongs on the right, so we throw it over, change its sign. It becomes positive x. And we didn't relocate the negative 7. We want that negative 7 to be on the right side of the equal sign, so let's keep it there. And it looks like we are done. The coefficient is positive 1, so we have y equaling mx plus b. Our slope is going to be 1, and our y-intercept when we graph it is going to start at -7. And the fraction for 1, if we're doing our rate of change, will be rise 1 and run 1. That'll come in handy later on. All right. The second equation, if we're solving, stabilize the y. Take that x term, which was positive, throw it to the right side, it becomes negative x. Don't change your value on the right, it remains -8. And now we have a coefficient that's greater than +1. So we need to make sure that we turn this +4 into a +1. And if we're doing our inverse operations of multiplying by 4, we're going to divide everything by that coefficient, which happens to be +4. And now we're going to simplify. 4 divided by 4 is 1y. Negative x over 4, well, the invisible number next to x is actually a -1. So we have -1/4 x as being the slope. -1/4 is the slope. And then simplifying, -8 divided by +4 is -2. And let's label each of our graphing components. The slope that we are working with is -1/4, and the y-intercept we're working with is -2. And let's go to a grid and graph each one of these lines. So the first line, the slope is 1, and the intercept is -7. We'll do that in pink. Just stay consistent here. All right, so if I go to the y-intercept, that's where the line crosses the y-axis at -7. So here's 0, -1, 2, 3, 4, 5, 6, -7. And from that point, we are going to use our rise over run. And we said that it's a 1. So we're going to rise 1 and run 1. Or to get the other side of the line, we can go down 1 and then left 1, because a negative divided by a negative is also that +1 slope. All right, so let's get that line. Rise 1, run 1, rise and run, rise and run. And you can see the line forming here for us. Take out a straight edge. It's very important that we're accurate. So we'll take our straight edge and draw a line through the points. And we actually don't even need these annotation dots anymore. So let me clear those out. Okay, so there is equation 1. Now we're going to have to go and get equation 2. And we had an intercept of -2 and a slope of -1/4. So we had I'm sorry, what was that one more time? So we're at -2 and -1/4. All right. So we go down 2 for the y-intercept. And now to get our slope of -1/4, we have two options. We could go down 1 and right 4, or we can go up 1 and left 4. Both of those mean -1/4. All right, so let's go down 1, right 4. 1, 2, 3, 4. Down 1, right 4. 1, 2, 3, 4. Down 1, right 4. 1, 2, 3, 4. Take out your straight edge. Connect your points. And let's clear the annotations. Looking for an intersection point, since I graphed both lines, I see an intersection point. It is right here. I can label it. If this is the origin 0, 0, we go 1, 2, 3, 4, and then down 1, 2, 3. So the ordered pair is 4, -3. Now, I'm going to take that ordered pair and put it back into my two given equations to check and see if the math works on them, just to double check. All right, so 4, -3. So the first equation is -x plus y equals -7. So I have negative, and then the x happens to be, what do we have up here? We have a 4, so I'll substitute in a 4 plus my y value. Well, what is my y value? It's a -3, and that should equal -7 if we did it correctly. So -4 plus -3 is in fact -7. So yes, it satisfies, the ordered pair satisfies equation 1. Let's check the second point. We have x being 4. Substitute in the y, which was a -3. Do the order of operations, multiply first. 4 times -3 is -12. Bring down the 4 that we didn't use. And 4 minus 12 is -8. So this one also checks it. And if it's a solution, I'm going to remind you again, if it is actually a solution to the system, you must have a yes in both equations for it to work. If one of them didn't work, then it would not be a solution to that system. It might work in one equation and not the other, which is fine, but it just wouldn't be the answer as the solution. All right, before I leave you here, I want to make a special note, and we'll talk a little bit more about this in class. If you put both of your equations into slope-intercept form, into our graphing form of y equals mx plus b, and you come up with a situation where your lines have the same slope, so if your m happens to be 2 in the first equation and 2 in the second equation, and your y-intercepts right here are different, there is what we call no solution to the system. And the reason why there's no solution is because those lines, when you graph them, the two lines, the two equations, they're going to be parallel. And if the lines are parallel, they are never going to intersect. And if they never intersect, they aren't going to be sharing a solution. So that means there would be no common solution between the two of them. That would be your answer. The second note I want to make here is on the bottom. If the lines are exactly the same in slope-intercept form, there's what we call infinitely many solutions. So for example, if I have y equaling 3x plus 1, and we rearrange the second equation, and it ends up being the same 3x plus 1, we know that those two lines, when you graph them, are going to lie right on top of each other, which means they would share all of these ordered pairs, which means there are infinitely many answers to that. Okay, in your journal, I'd like you to define the given terms on page 2 of the flip chart, write a few sentences on what you learned from this video, and make some markings in your journal. If you have any types of questions on anything that I just went over, please bring those questions to class and we can answer them together.